Student, welcome to today's class. Yesterday we were discussing this topic on ignition system, and we say we have these types of ignition system. One, we have coil ignition system, we have electric ignition system, and lastly we have magneto ignition system. Now yesterday we were able to look at the coil ignition system, so today I want us to discuss about electric ignition system. In electric ignition system also, we have two types of electric ignition system. One, we have transistorized ignition system and the capacitor discharge ignition system. The advantages of electric ignition system are, we are comparing the electric ignition system over the coil ignition system. One, we are saying one of the advantages of using the electric ignition system is that it has a low maintenance. All the maintenance of the electric ignition system is a bit low. We have also it produce high power compared to coil ignition system. It produce high power. We have a less air pollution, and on the operation it has less air pollution, and we have also less fuel consumption. And lastly we have produce high secondary voltage required for the spark plug. So it produces high voltage required for the spark plug. Now, as we move to the electric ignition system, we have what we call triggering system in electric ignition system. We have three triggering systems. One, we have all effect generator. We have the optical impulse, and lastly we have inductive impulse. Now, to start with, let us look at the transistorized ignition system. This is the system. You can see we have the whole effect generator as a triggering. In this system, we have the coil winding, we have transistors T1, T2, and T3. We have the resistance, we have the capacitors. The function of a capacitor is just to store charges for a moment. We have the coil, or the solenoid here. We have the distributor and the spark plugs. Now, let us see what happens in this system. Now, remember yesterday we said there is a difference when you start the engine, when you put the engine on, and when you start the engine. Now, when you put the engine on, remember we said all electric components are operational. You can switch on the light and all that. You can tune the radio and all that. Now, when you are starting the engine, you are cranking the engine. Now, let us see what happens when you are starting the engine. When you are putting the engine on, the current will flow through R1. To the transistor T2, switching transistor T2 on. The current also flows to the transistor T3, switching the transistor T3 on. Now, T2 and T3 are on because we are saying the current will flow from R1 to the transistor T2, switching T2 on, to the transistor T3, switching transistor T3 on. Now, this transistor is supposed to emit the current through the correct emitter. This is the correct emitter. It is supposed to emit the current through the correct emitter. But now, you can see we have a Zener diode here. This is a Zener diode. We have a Zener diode. This is a one-way valve that allows the current to flow in one direction only. For instance, in this case, this Zener diode will allow the current to flow in that direction. Now, the current coming from this other direction will be biased. So, this current, because of the Zener diode, it will not flow through the correct emitter. It will be forced to flow through the corrector, and it will be forced to flow to the corrector to the primary winding. Once it reaches the primary winding, a magnetic field is created. Remember, this is a solenoid. Once the current reaches the primary winding, a magnetic field is created. A capacitor there is there to store charges for a moment, as we are saying. Now, we have the magnetic field being created. That is the end of when the engine is on. When you move to when the engine is started, a small voltage is induced by the Hall effect generator. A small voltage is induced by a small voltage is induced by a Hall effect generator to the coil winding. Small voltage jumps to the coil winding. This small voltage is taken or moves to the base of T1, sorry. It moves the base of T1 transistor T1, switching transistor T1 on. Switching the transistor T1 on. Once the transistor T1 is on, the current which was flowing through R1, the transistor T2 and T3, realize that there is a lot of resistance. It is being forced to flow to the primary winding. Now, it experiences that resistance, high resistance. Now, because of T1 is on, this current which was flowing this direction will be redirected. The current which was flowing through R1, T2 and T3 will be redirected to the transistor T1 to the correct emitter of the transistor T1 to the correct emitter of the transistor T1 because the T1 is on. Now you can see this one. That doing by redirecting the current to flow to the transistor T1, the transistor T2 will be off and the transistor T3 will be off. Meaning there will be no current flowing to the primary winding. So there being no current flowing to the primary winding, the magnetic field which was created here collapses, achieving a very high voltage to the secondary winding required for the spark plugs. Now the spark plug through as the distributor, in the distributor we have a rotor. As the rotor rotates, we'll be able to divide or to take the current to the spark plug, the required spark plug. Then the spark plug will produce the sparks to each and every cylinders. Thank you. We shall proceed from there.